everyone, this is Shalini Sheetal here. I'm a computer science sophomore from NIT Rourkela and I'll be guiding you guys through various concepts regarding C programming. Now C is a very powerful general purpose programming language. It was originally developed by Dennis Ritchie in the year 1972 and since then it has been used to develop softwares like operating systems, compilers, databases and so on. C is actually a very useful tool to learn to program for beginners. This presentation will guide you through the concept of functions in C one step at a time. Now what exactly is a function? A function is a group of statements that together perform a task. It is actually a block of statements. Every C program has at least one function which is the main function. It is actually the driver function. No C program can exist without main. Other than that, every program has the liberty to define as many functions as it can. Now, functions are standalone entities. They can be defined either in the same file or in some other file. They are mutually independent. Also, they can be compiled separately and loaded as desired. As many functions with the same name can exist in the same program, provided they take different arguments or are of different return types. Why do we need to use functions? Now see, a C program can either be written in the generic style or in the Modulus style. What's the generic style? It's the usual way of writing up your code sequentially, step by step. But in the Modulus style, you divide up your code into different functions. The way you divide up your code is completely up to you. But logically, the division should be such that each function performs a specific task. Now suppose you need to draw a circle and color it. Then you have to define two functions. One to draw the circle, the other to color it. Now what's wrong with the generic style? Why do we need to use functions? Firstly, in the generic style, it becomes difficult to understand the programming logic and hence find the error if any. But in the Modulus style, the code becomes much simpler to understand because you divide up your program into smaller chunks, right? So that's way simpler. Secondly, in the generic style, the code cannot be reused. But in the Modulus style, the same function, the same piece of code can be called again and again by the user and hence reused as many times as required. So you should definitely opt for the Modulus style of writing up a code if you write one. This program will actually make the concept quite clear of why do we need to use the Modulus style of writing a program. This is actually a simple program. You need to find the GCD of two numbers and then the factorial of the GCD. As you can see, this is the main function, the main part of the program. The variables are first declared. X is initialized to 0, Y as 12, Z as 18, A as 1 and B as 0. Now there are two while loops. The first while loop finds the GCD of the two numbers. The second while loop finds the factorial of the GCD. Now let's see how the first while loop is executed. In the first while loop, X is first assigned the value of Y modulo Z. What's Y here? It's 12. What's Z? It's 18. So X is assigned the value of 12 modulo 18, which is 12. The remainder of the division is 12. So X is assigned the value of 12. Nextly, Y is assigned the value of Z, which is 18. Z is assigned the value of X, which is 12. Then the while loop is executed again. This time, X is assigned the value of 18 modulo 12, which is 6. And Y is assigned the value of Z, which is 12 in this case, and Z is hereby assigned as 6. Now, if you look into it, the next while loop won't be executed. Why is that? Because in the third case, X becomes Y modulo Z, which is ultimately 12 modulo 6, which gives X the value 0. This while loop is executed only if the value of X is non-zero. So the third time while loop won't be executed. and we are left with the initializations of x as 0, z as 6. And here z is the GCD, so GCD is 6. The second while loop then gives the factorial of the GCD. We move into that next. As you can see, the z value is decremented again and again until it becomes 0. Once it becomes 0, we come out of the while loop. So z is first 6, then it becomes 5, 4, 3, 2, 1. The product is the factorial, and we get the factorial of 6 as the ultimate answer, which is printed. Now let's look at the same program written in the Modulus style. It's basically the same if you look at it quite carefully. The main function is declared in the same way, but in this case, the two while loops are replaced by two functions. One function is in GCD, which gives the value of GCD of the two numbers, and the second function is the factorial, which is used to find the factorial of the GCD. If you look at it, the factorial program and GCD program are both called from the int main function and hence executed. But if you look at it, it's quite easier to understand the program this way, as there are clear distinctions of what we exactly need to do in the program. Hope it becomes clear. Nextly, we look at types of functions. Broadly, functions are classified into two types. One, user-defined functions. Second, standard library functions. What are user-defined functions? User-defined functions are developed by the user as per the requirements. The user has the liberty to define the function in the way he or she wants. But standard library functions are predefined. They are not needed to be written by the user. They are present in the standard library and hence are called standard library functions. Now this is the syntax of a user-defined function. Firstly, we include the header files as required. Then this part of the function, the next part is the definition. And the definition, after the definition, we have written the main function, from where the function is actually called. This picture will give a clearer dimension of the scenario. Firstly, in every program, the control of the program begins from the main. So first, the statements in main are executed, and thereby the control goes to the function. If you look at this in this case, firstly the statements in main are executed until the statement which calls the function is encountered. Then the control of the loop goes to the inside of the function. The statements inside the block of the function are executed, and then the control comes back to the main function and remaining of the statements are executed. Now let us become familiar with some of the standard library functions. They are quite important, as you will see. The first header file is the stdio.h. This is the basic header file. It is used in almost every program. It stands for standard input and standard output functions. It is used to perform input-output operations, as quite clear from the name. These are some of the most commonly used stdio functions. The first is printf. It is used to display the output of the program. The second is scanf. It is used to take input from the user. GetChar is used to return characters on the screen. PutChar is used to display output as a single character on the screen. Fgets is used to take a line as an input. Puts displays a line as the output. Fopen is used to open a file. Fclose similarly is used to close a file. The names are quite related to the functions if you see. Nextly, the next important header file is string.h. Basically, there are 9 most commonly used functions in the string library. The first is strcat. It is used to concatenate two strings, to join two strings. Second is strchr. It is used for the scanning operation. Next, the strcmp. It is used to compare two strings if they are same or not. strcpy is used to copy a string from one to another. strlen returns the length of the string excluding the null character. strnca8 is used to concatenate one string with part of another. These are part by part functions. Similarly, strncmp compares two distinct paths of strings. strncpy copies a part of a string to another, and strncgr is the string scanning operation. The next important header file is math.h. There are numerous functions under this and are quite useful for mathematical operations. The first is abs, that returns the absolute value of an integer. It can only be positive. Next is floor. It returns the nearest integer, which is less than or equal to the argument passed to the function. Round. The function returns the nearest integer value of either the float or double or long double argument passed to the function. Next is ceil. It returns the integer, the smallest integer, which is greater than or equal to the argument passed to the function. Its job is actually opposite to that of the floor, as the name again clearly portrays. Next, sine and cos. They return the respective sine and cosine values of the arguments. Next is cosh. As the name indicates, it returns the hyperbolic cosine value of the argument passed. Next is exp. It returns the exponential e to the power of the argument. Next, similarly, tan and tanh respectively return the tangent and hyperbolic tangent of the arguments passed. Similarly, sin returns the hyperbolic sine value. Now these are the logarithmic functions. The next lot are the logarithmic functions. Log returns the natural logarithm to the base e. Log10 returns the logarithm with the base 10. Nextly, sqrt returns the square root of the argument. This would be naturally very helpful. You don't need to write a long piece of code to find the square root of a number. You can simply write sqrt of the required value and the function returns the square root value. Similarly, POW, the power function, returns the power of the given number. You can specify the base and also the power. Lastly, trunc. This function truncates the decimal value from the floating point value and returns just the integer value. Hope you are quite clear with the math functions. Now, what are the advantages of using C library functions? Why don't we define functions as per our need? First and foremost, the most important point is that standard library functions work. It can be a sure shot call that using standard library functions will give the right result. There is a guarantee that they will never give a wrong answer. Secondly, they are optimized for performance. See, there is a dedicated group of programmers who constantly modify them for much better performance. So they create the most useful and efficient logic and hence return the right answer. Thirdly, it saves considerable amount of time. Suppose you need to find the square root of any number. Then if you use a standard library function, you can write up your code within minutes. Whereas if you need to write up the logic for the code, you need a much larger amount of time. It will consume a lot of time and hence be inefficient. Lastly, functions are portable. In this real world scenario, you need a code which works almost in every computer, no matter what the surroundings are. These standard library functions will work wherever you put them to use. So definitely, using C library function is a much wiser option than defining your own functions. If for a purpose a C library function exists, then go for using that function directly instead of wasting your time on writing up the logic behind it. Nextly, we see the steps required to execute a function. The first part is defining a function. This is the syntax of defining a function. You need to mention the return type first, then you need to give the function a name, and then you mention the parameter list, the arguments which are passed to the function. Then inside curly braces, inside the block of the function, you need to write the body of the function, which is the group of statements which will perform the task of the function. Secondly is the function declaration. This function declaration tells the compiler about a function name and how to call the function. If you carefully look at it, the function declaration is just the heading of the defining of a function without the body and plus with a semicolon. Lastly, calling a function. Now to use a function, you will have to call that function from inside the main or some other function. If you don't call the function is not invoked and it will not perform its task. So this is the syntax. To call the function, you just need to mention its name and pass the parameters as required. Now what are these parameters? What are these arguments? What is the return type? Return type. A function may return a value, right? Or it may not. The return type is of the data type the function returns. If it returns an integer value, the return type of the function is integer. If it does not return any value, any kind of value, then return type of the function is void. Void depicts null. Next, the function name. It's the name of the function. You can give it whatever you want, provided these aren't used keywords. Now the parameters. A parameter can be called as a placeholder. When a function is invoked, you pass a value to that parameter. This value is referred to as the actual parameter. The parameter list refers to the type, the order, and the number of parameters of the function. Parameters are optional. You can add them if you want or not. Lastly, the function body. It is the block of statements, the collection of statements that perform the logic the function is designed to. Nextly, this program will actually help you to understand what are the steps of a function. Firstly, you include the header file as required, stdioh. Then you need to declare the function first of all. Here it is defined as the max function. It takes two inputs, two parameters. One is of integer value, num1. The other is also of integer value, num2. Nextly, you defined all the local variables as required. Int a is assigned 10 and b is assigned 200. Nextly, you define another integer, which is the ret, return. Nextly, you call the function. As you can see, ret value, as mentioned earlier, it stores the value the function returns. The function is called max of ab. The control of the program goes straight to inside of that function. If you see, the statements are then executed. The result is assigned the value of the larger of the two numbers by using comparison, and then the result is returned. If you see the last statement of the function max, the result is returned, which then goes and gets stored in the ret variable and then return 0. As the function main does not return any value, you can write it as return 0. So here the value of ret gets printed, which gives the larger of the two numbers passed. Now let us move on to function arguments. There are basically two types of arguments. First are the formal parameters. The next are the actual parameters. The formal parameters are like any other local variables. They are created upon entry and destroyed upon exit. They are not permanent. They are not given by the user. They are just created inside the function, executed there, and then they are destroyed upon the exit of the function. But the actual parameters are the ones which are passed by the user. They are treated as local variables within a function and they take precedence over global variables. Now what are global variables? That's entirely a different topic. But just remember, actual parameters are the ones which are passed. Nextly, let us look at the two ways in which arguments can be passed to a function. Basically, there are two ways in which arguments can be passed to a function. The first one is called by value and the second one is called by reference. In the first method, in which you call the arguments by value, the actual value of an argument is passed into the formal parameter of the function. In this case, changes made to the parameters inside the function have no effect on the argument. It means that the original values of the parameters go unchanged. They are just modified within the scope of the function or within the body of the function, and once the function is executed completely, the original variables remain as such. They are not at all modified, they remain the same. But if you call them by reference, which is the second method, then in this method, the address of an argument is copied into the formal parameter inside the function. In this method, the addresses are used to access the actual argument, and in this method, the changes made to the parameters affect the argument. This means that whatever the changes are produced by the function on the variables, they are reflected upon on the original variables. The changes don't go unnoticed. The variables are modified, they are changed, they are modified by the function. So this is basically the difference between the two. Now let us go into the details of calling a function by value. The call by value, as mentioned before, is the method of passing arguments to a function by the actual value into the formal parameter of the function. In this case, changes made to the parameter inside the function have no effect on the argument. As mentioned before, again, the original variables remain unchanged. The changes go unnoticed. They remain the same. Just the values are copied, they are acted upon inside the function, and they again come out the same. No changes are reflected. The thing is that by default, C programming uses call by value to pass arguments. If you don't mention that you need to call them by reference, then C assumes that you are calling them by value, and hence, in general, it means that the code within a function cannot alter the arguments used to call the function. The parameters remain as such, the original variables are unchanged, and they remain the same. C calls by value as default. Now this program will actually make the concept of calling by value quite clear. Let us consider the function swap. It is used to interchange the value of two variables. Suppose there are two variables A and B, then A is assigned the value of B and B is assigned the value of A. This is the prototype used to swap two variables by using another temporary variable. Here in this case it is temp. It is just created inside the function and destroyed upon exit of the function. This is the prototype to interchange two variables, to swap two variables using another variable. There are also other methods, but we'll just look at this method in this case. Here the function is defined, void swap. Int x and y are the two integers which are passed into the function whose values you need to interchange. Then another temporary variable int temp is declared. Then first of all, temp is assigned the value of x. The value of x gets saved into temp. In the second step, x is then assigned the value of y. The value of y is put into x. And in the last step, y is then again assigned the value of temp, and the value of temp is put into y. After the explanation of the function, after using actual data, the concept will become quite clear. After the execution of the three statements, the function is again returned. So let us look at the program. First of all, you include the header files as required. Then you declare the function. It's the usual method, void swap, as the variables passed are of integer type. They are labeled as int x and int y. Then comes the main of the function. Here the local variables int a and b are required. A is given the value of 100, for example, and b is given 200. First of all, let us print the original values of the variables. A is 100 and B is 200, so the output will be given using the printf statements. Then we call the swap function. It takes the variables A and B as the arguments, and the function swap, as we mentioned before, is called. Then let us look at what happens inside the function. As you can see here, int x is assigned the value of 100 and int y is assigned the value of 200. Then again, as mentioned before, the temporary variable temp is declared. Then here, temp is assigned the value of x. The value of x is 100, so temp becomes 100. In the next step, x is assigned the value of y. Y is 200, so x becomes 200. And in the last step, y is assigned the value of temp. So y becomes 100 as temp has already become 100. If you see at the end, x becomes 200, which was originally the value of y, and y becomes 100, which was originally the value of x. So at the end of this function, the two values get interchanged. They are modified, they are swapped, and then the function is returned. The control then again goes back to the main function, and as you can see, the printf statements again prints the output of the changed variables this time, not the original ones. The original ones are printed already, while this again prints the output values of the changed variables. First A is printed, and similarly, following the earlier pattern, B is printed. Let us see what happens actually. You have called them by value, not by reference. So let us look at the output. The first output is of the original variables. Before swap, value of A and B are 100 and 200 respectively. But if you see after swap, even after the swap function is called, the value of A and B remains still the same. They are 100 and 200. They are not changed, they are not swapped. If you look at it in a broader way, one can say that the function swap has been useless. It has not been executed, but that's not right. It has been executed, but since you have called them by value and not by reference, the values remain as such, they are not changed. This is the issue with call by value. They have just been changed inside the function, but once they come out of it, they remain the same. You can correct this if you use the value of call by reference. Now what happens in this case? What happens when you call by reference? The call by reference method of passing arguments to a function copies the address of an argument into the formal parameter. In this case, the address is copied. The value is not copied. So when you access them inside the function, you actually access the addresses of the arguments, the addresses of the variables, and as a result, the changes are reflected upon the original variables. This time, the changes don't go unnoticed. They are reflected on the original variables. They are changed, they are modified as the function does. So whatever the statements are executed, they are again reflected upon on the original variables. So accordingly, you need to declare the function parameters as pointer types, as in this case you are accessing the addresses. So you need to use pointer references. We'll look into pointers in later videos, and the concept of pointers will get clearer later. But just remember that when you are calling by reference, then you need to declare the arguments as pointer types, because whenever you need to access any addresses, a pointer is used. Let us look at the same program by using the call of reference method. What's the difference in this case? If you look at it, it's actually the same method, but in this case, the variables inside the function swap, inside the argument list, the parameter list, are declared as pointer types. The asterisk sign clearly indicates that pointer types are used. Other than that, the prototype remains the same. First of all, the original variables are printed, the value of A and B before swap function is called, and later after the swap function is called. But remember, when you are passing any values by reference, you need to add the ampersand sign, which is the AND sign. The compiler will understand that you are actually passing them by reference and not by value. So when you pass by reference, the addresses are accessed and the changes are reflected outside of the function also. Let us look at the output in this case. Remember, in this case, you use pointer references, not just integer types, you use pointers. The asterisk sign indicates that x and y are pointers in this case, which access the address of the variables passed and not the values. Now, in this case, if you put the above code into a single C file, compile it and execute it, this is the output you'll get. Before swap, value of A and B are 100 and 200 respectively. But after the swap function is executed, this time values of A and B get interchanged. Now value of A is 200 while the value of B becomes 100. The code has been successful, the function has been executed logically correctly. Remember, logically. And the functions give the output as the value of A is 200 and B is 100 after the swap. Now this shows that when you call by reference, changes are reflected outside the function as well, unlike call by value where the changes do not reflect outside of the function. So when you want that the changes are needed outside of the function also and not inside just of the function, remember to call the arguments by reference. Now, this is an overview of the differences between call by value and call by reference in C. In call by value, a copy of the function is passed into the function, while in call by reference, an address of value is passed into the function. Secondly, changes made inside the function in case of call by value are limited just to the function and not outside of the DAG. The values of the actual parameters do not change by changing the formal parameters. The changes are just acting upon the formal parameters and not the original ones, not the actual ones. But when you call by reference, changes made inside the function also are validating outside of the function. The values of the actual parameters do change by changing the formal parameters. And lastly, actual and formal parameters in case of call by value are created at different memory locations. But when you call by reference, actual and formal parameters are created at the same memory location. Remember, you are accessing the address. So the address has to be one specific location. You can't create two different addresses at the same time, right? So you are accessing the same address and hence the changes are reflected upon outside of the function as well. But in call by value, you are using two different memory locations, one for the formal ones, one for the actual ones. So these changes are just reflected upon the formal ones and not the actual ones. But in case of call by reference, you are accessing by address, it's the same location, so naturally the changes get reflected upon outside the function. Hope the concept of call by value and call by reference are clear. It's quite important in the concept of functions. Now, let us look at some important points about functions in C, an overall view, a general view. Firstly, every C program has a function called main. I've already mentioned earlier, it's the driver function of the program. Any program can't be executed without the main function. It is called by the operating system when a user runs the program. It's the first function which gets executed. So remember to add the main function definitely. Secondly, every function has a return type. If it doesn't, then it is declared as void. Void is used as the return type. Moreover, if the return type of the function is void, we still can use the return statement in the body of the function by not specifying any constant or variable. Now, you just need to write the statement return, semicolon, and it would symbolize the termination of the program. The program would end right then. Now, the third thing about functions is that in C, functions can return any type, any type of variable, be it integer, be it float, be it double, character, anything. But it cannot directly return arrays and functions. If you wish to return arrays and functions, then you can do that by returning the pointer to that specific array or that specific function. Pointers are very, very important. You can use pointers to return functions or the arrays, but you can't return them directly as you do with any integer value or float value or character value. The next thing is that an empty parameter list in C means that the parameter list is not specified and function can be called without any parameters. This is an example. Suppose fun. No parameters are there inside the brackets of the function, right? No parameters are there. You can define that in that way, no issues. But the thing is that in C, it is not a good idea to declare a function just like that, fun, brackets, no. To declare a function that can only be called without any parameter, we should use void, fun, and again inside the brackets, mention void. Use the word void. It's actually a good programming practice. The next thing, last thing, is that if in a C program, a function is called before its declaration, then the C compiler automatically assumes that the declaration of that function is in the as mentioned way, int function name. Default return type is int. If you don't declare it beforehand, the compiler will assume that the return type of the function is int. So if you wish that the return type of the function is something different, either float or a structure or something else, then remember to declare it first time. Nextly, let us look at what is function overloading. Now, when we use different functions, multiple functions with the same name, but different parameters, then they are called overloaded. This technique is actually used to enhance the readability of the program. Why do we need to overload a function? Suppose you wish that a same function, suppose adding two variables, is called from the main function. But if you have already declared the return type as int, you cannot use that specific function for float variables. The logic is same, the work it does is just adds two integers or two variables. But just because it needs different variables or you need to give different variables, you can declare another function with the same name, saying add, but with float return type. The logic of the function would be same, it will be executed in the same way, but there will be two different functions present, one for the integer type and one for the float type. Now how can you differentiate between two overloaded functions? They are said to be different if they have different number of arguments or have different argument types. The argument types can be integer if you wish to add two integers, or float if you wish to add two floating point numbers. So this is the logic behind function overloading. Now you see, the thing is that C doesn't support this feature. These were added later in various programming languages, but C being a primitive one, C doesn't support function overloading. It is this feature is present in most of the object-oriented programming languages like C++ and Java, but not C. C is not an object-oriented programming language, so it doesn't support this feature. So keep in mind, C doesn't support function overloading. The next thing are the concept of nested functions. It's a common misconception actually that defining a function inside another function is known as a nested function. But it's not a nested function in reality. The reality is that it is actually termed as lexical scoping. There is no such thing as nested function. It's the term given for that is lexical scoping. Again, lexical scoping is not valid in C because the compiler cannot reach the correct memory location of the inner function. It gives a compile time error if you declare or define another function inside a function. Nested function is not supported by C because we cannot define a function within another function. That's the basic definition, right? It cannot be done so. Because we cannot define, but there's another way. We can declare a function. Declare, not define, inside a function. But again, it won't be termed as a nested function, because nested function definitions cannot access local variables of the surrounding blocks. They can only access global variables which are declared outside of all the scopes and functions. If you try to approach nested function C, then naturally we'll get a compile time error, because the compiler cannot reach the location, right? So it gives a compile time error. Another important point is that an extension of the GNU, the C compiler, allows the declarations of nested functions. The declarations of the nested functions under GCC's extension need to be starting with the keyword auto. If you mention auto, then you can declare the function inside of another function. Let us look at the result if you define another function inside a function. In this case, inside the main function, the fun function is first of all defined and the statements are mentioned. But inside the fun function, another function, term view, is defined. So as you can see, the output will give a compile time error and undefined reference to view. The compiler is unable to reach the location of view, so it gives an error. Now let us look at recursion. Recursion is the process which comes into existence when a function calls a copy of itself to work on a smaller program. Recursion means calling a function again and again when a function calls itself repeatedly. Any function which calls itself is called a recursive function, and such function calls are called recursive calls. Recursion involves several numbers of recursion calls. However, it is important to impose a termination condition, otherwise the recursion would be called again and again and again, and it would be executed infinitely. Now, recursion cannot be applied to all the problems, but it is more useful for the tasks that can be defined in terms of similar subtasks. For example, recursion can be applied to sorting, searching, or traversal problems. They are mainly used when you need to access the function again and again, or when you need to call one specific block of statements again and again. Now let us look what's the issue with iteration. Why to use recursion? First of all, recursion code is shorter than iterative code, but it is difficult to understand. You need to have a prior knowledge. Secondly, iterative solutions are more efficient than recursive functions. Any problem that can be solved recursively can also be solved using iterations. Iterations are quite simple to execute, right? But some problems can only be solved by recursion. For example, Tower of Hanoi, Fibonacci series, factorial finding, etc. These are different problems which can be only solved by recursion. Next thing, it's not necessary that you can only use recursion, you can use iteration, but recursion will be a wiser option. Now nextly, the case at which the function doesn't recur is called the base case, but when it keeps on calling again and again to itself, it's called a recursive case. As the name clearly indicates it, all the recursive functions can be written using this format. Now this program illustrates the concept of recursion in C. First of all, you include the header files as required, you declare the functions fact. This function actually is used to find the factorial of a number by using recursion. Then you declare the local variables and you ask whose factorial do you need to print. Then you take the input as the user gives it, and then you call the function fact. Then the control of the program goes inside of the program fact, the function fact, and if the number given is 0, then naturally 0 is returned as the factorial can't be done. So if n is 1, then the value is written as 1, and in the last case, or else if it is a valid number, you return the value of n into factorial of n minus 1. See, fact n minus 1 is actually calling the function again, but this time with the value n minus 1. This function gets on calling again and again and again unless and until it becomes 0. So the output will be given, if you input 5, then the factorial of 5 would be given as 120. This picture will make the concept quite clear. Suppose 5 is given, then in that case, first of all, 5 into factorial of 4 will be called. The control again goes back to the starting of the function. The statements get executed again and again, and 3 is returned. In this way, the values get multiplied again and again till it becomes 0, and then the value of factorial becomes 120. So I hope I could briefly explain the concept of functions in C in this presentation. I hope you guys liked our video. Thanks a lot for your time and patience.